Hello everybody, welcome to topic number 16, solving quadratics by factoring. In this video, we're going to show you how to solve polynomial equations by factoring and solve problems that could be modeled by polynomial equations. So over the last couple of videos, we've taken you through different factoring techniques. We've shown you how to be able to go through and factor using the greatest common factor and any sort of polynomial. We've shown you that if you have 4 terms that you could factor by grouping. If you have 3 terms, you can use the a equals 1 or the AC method to factor it. Or if you realize that you have perfect squares, you could do perfect square trinomial. And then if you have 2 terms, that you could do the sum and difference of cubes as well as the difference of squares. Now you're going to be using these techniques to actually solve equations, to go through and find out values of x. So one of the things that we need to do now is be able to look at a polynomial and realize how to be able to factor it. So we always check for a GCF as we do this, and then most of the time we're going to look at the number of terms to be able to help us figure out the rest. For example, we know if we have 4 terms, it's probably going to be factoring by grouping. Whereas if it has 2 terms, we'll have to go through and see, is it difference of squares or is it sum or difference of cubes? Now it is up to you to know how to go through and factor this. Before we get into solving quadratics, let's take you through the zero product property. The zero product property states that if the product of 2 numbers multiplies and equals 0, then one or both answers must be 0. So when you look at it from a logical aspect, if I have a times b and it equals 0, the only way that works is one of 2 ways. Either I have 0 times b to get me 0, which means that a is equal to 0, or I have a times 0 to get 0, which means in this case b is 0. But either way, one of those has to be 0, or the other logical way is that they're both 0. So we use the zero product property as a way to be able to help us solve equations. We assume that all the answers are 0 and find any solutions that work for that. So for example, when I take a look at this problem, this might be a problem that we went through and we already factored. So when we factored, we were left with the x plus 8 and x minus 5. But now we have it set equal to 0, and we're trying to solve for x in this case. We're trying to find all the values of x that will make this work. So we learned with zero product, if 2 things multiply to be 0, we're going to assume each one of them could be 0. So we're going to take each one of these and set them equal to 0 and find out what x could be. Here, x plus 8 equals 0. I would minus 8, and I would find x to be negative 8. Which means if I went back in and plugged in negative 8 to both of these, negative 8 plus 8 would be 0, negative 8 minus 5 would be negative 13, but 0 times negative 13 gives me 0. That would be one of my solutions. Same thing here with the second one. I would add 5 to get x by itself, and I would find that x is equal to 5. So while I do 5 plus 8 and get 13, 5 minus 5 is 0. 13 times 0 gives me 0. This tells me these are the only 2 values of x that I can plug in and get back an answer of 0. Because again, the only way I can get 0 is if one of those 2 multiples is 0 itself. So how do we solve quadratics by factoring? First, we're going to write the equation in standard form, where we put one side of the equation equal to 0. If it's already equal to 0, you can skip this step. We also want to make sure, as we do this, our polynomial is written in descending order, meaning we'll put the highest exponent first and work our way down to the lowest exponent or the constant. We'll then from there need to determine the factoring need by looking at the number of terms. So this is where we'll go through and ask how many terms do we have and what type of factoring technique could we use. We'll also make sure that there's no GCF at this point before we determine the factoring need. We'll then factor it like a normal problem, but then when we get down to the answer part, we'll use the zero product property to solve and find our solutions. So you can think of this as just an extension of all the factoring videos we've seen over the last 3 videos, where we're going to factor it, but now we're going to take all of those factors and set them equal to 0 to solve the problems. Let's show you a couple of examples. So in letter A, we don't need to set it equal to 0 because it's already there. So now we have to determine the factoring technique to use over here. some of the things we realize. It has 3 terms, and a is equal to 1. There's nothing in front of x squared. So this should be the factoring technique that we need to use here. We're going to go through our a equals 1 factoring technique. That means we got to find some number that multiplies to c, which is 30, and adds to b, which is negative 11. So I'll list my multiples of 30. 1 and 30, 2 and 15, 3 and 10. We've got 5 and 6. I'm looking for something that can give me an 11. That would be 5 and 6. I need it to be a negative 11, and I need to multiply to be positive 30, so the signs have to be the same. So it's got to be negative 5 and negative 6. So this would generally factor to x minus 5 and x minus 6. But now we're setting them equal to 0. We're trying to find the values of x that would work in this case. If two things multiply to equal 0, we set each of them equal to 0 and find what their solutions could be. So if x minus 5 equals 0, that means one of the solutions is x equals 5. And we'll do the same thing over here. The other solution has to be x equals 6. So the only two solutions that work are 5 and 6. Taking a look at b, we again have it already set equal to 0, so we don't need to do anything there. It's got 3 terms, but now a is greater than 1. The a is 6 in this case, which means I need to use the AC method to try and factor this. So let's go through our AC method steps. We'll take a times c, so 6 times 6, which is 36. It's got to multiply to 36 and add to 13. We've got 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. The only thing that can get me to a 13 is 4 and 9. I need this to be a positive 13, and I need this to be positive when I multiply, so the signs have to be the same. So both of these have to be positive. Remember, this goes right into grouping. So the 6x squared, and then the 2 terms from here, plus 4x, plus 9x, drop down to 6, and it all still equals 0. So as we're doing this, we're basically ignoring the equals 0 until the end when we do our solution. We'll now take this, and we'll go through and group it. We'll find the GCF of the first group, 6x squared and 4x. 6 and 4, you could take out a 2. X squared and x, you could take out an x. So I'll divide everything by 2x. 6 divided by 2 is 3. X squared divided by x is x. 4x divided by 2x just gives me 2. We'll take the GCF from the second group, 9x and 6. 9 and 6 have a 3 in common, so I'm going to divide everything by 3. 9x divided by 3 is 3x. 6 divided by 3 is 2. Remember our check for when we do grouping. These should come out to be the same, which they did. So if we were factoring, our final answer would simply be 2x plus 3 and 3x plus 2. But now this is set equal to 0. So we're going to use our 0 product property to finish this. We're going to take each of these problems and set them equal to 0. So as I do that, it's a 2-step problem. I'll minus 3 over here and divide by 2. So one of my solutions is negative 3 over 2. Here I will go through. Oh, wrote the wrong one. Let me fix that. Over here, this one should be 3x plus 2 equals 0. So we'll minus the 2 and divide by 3, and we get negative 2/3. So now we have two answers again. One of the answers is negative 3 over 2, and the other one is negative 2 over 3. Both of these would be included as part of our answer. Taking a look at C, now it's not set equal to 0. So before we go through and determine any sort of factoring technique, it needs to be set equal to 0. So we're going to move this 70 to the other side. We get rid of a positive 70 by minusing it to the other side. None of these are like terms over here, so we'll leave it x squared plus 3x minus 70 equals 0. Now that we've got it set at equal to 0, we can pick our factoring technique. It's nothing to have greatest common factor wise. It's got 3 terms and there's nothing in front of the x squared. So we're going to use a equals 1 to factor this. We need something that multiplies the negative 70 and adds to 3. Well, we know that 7 and 10 can get us there. It's got to be a negative 70, so these signs have to be different to make it a 3. So I need to do 10 minus 7. 10 minus 7 is positive 3. 10 times negative 7 is negative 70. This would become x minus 7, x plus 10. And if we were factoring, that's all we would do there. But now we're going to take each of these and set them equal to 0 and find their solutions. Typically when you have x by itself, it's just the opposite here. So here, x is equal to positive 7. And since x is by itself here, I move the 10 by subtracting it. X would be negative 10. Those would be the only 2 solutions we have here. Again, on D, we do not have it set equal to 0. And before I move this over, I want to get rid of these parentheses and make this into a nice polynomial. So I'm going to take this x and I'm going to distribute it out. X times 3x is 3x squared. X times 4 is 4x. And that's equal to 4. I'm going to minus both sides by 4. It's not going to combine with that 4x because it doesn't have an x on it. And now it's equal to 0. So here we can go through and look and see what type of factoring technique is needed. There's no GCF that they have in common. I see it's got 3 terms, but this time there's something in front of the x squared. So this is going to be the AC method we need to solve this. A times C, we've got 3 times negative 4, which is negative 12. And it's got to add up to 4. We got 1 and 12, 2 and 6, 3 and 4. I need 2 and 6 to get me to 4, so we'll go 6 minus 2. And remember, we gotta figure out which one we're altering. We're altering this problem when you do it. So we're gonna go 3x squared minus 2x plus 6x minus 4, and we'll keep bringing that 0 down for the ride. Here, these will go through and we'll do grouping here. 3x squared and 2x, I can only take out an x. That leaves me with 3x minus 2. 6x and 4, between 6 and 4, I can take out a 2. Again, leaving me with 3x minus 2. So if I was doing just factoring, my factoring answer would be x plus 2, 3x minus 2. But now we're going to take each of these and set them equal to 0 to find our solutions. This one's got x by itself, so I'm just going to flip this. X here is negative 2. Here we'll do the 2 steps. I'm going to add the 2 to the other side and divide by 3. So I get my solutions to be negative 2 and 2/3. Make sure when you go to put that into my math lab or for your answers for your homework, you give me both of those as the solutions. Does not matter which order you put them in, but I do need both solutions in this case. Again, neither of these problems are set equal to 0, so we're going to get rid of the parentheses and get it equal to 0. Here, I'll distribute the x, and I have x squared minus 8x equals x squared plus 5x. I go to try to move the x squared to the other side, but I notice they both cancel. So in this case, I've got negative 8x equals 5x. Now it's just a linear problem. There should be no factoring. Our goal is just now to get x by itself. I'm going to take this 5x and move it to the other side by subtracting it. Here that cancels. Negative 8x minus 5x is negative 13x. And here these canceled out, so I don't have anything. That is a 0. Negative 13x equals 0. I'll divide both sides by negative 13, and I get x equals 0. So I know I didn't have to factor this time because I lost the x squared. If I don't have any x squared and I just have a single x, then no factoring is needed. I'm just going through and solving it like an original equation. Typically, if I have something that's x squared, I know that I need to factor. Or if it's higher than x squared, like an x cubed, I know I need to factor. Same thing for f, but we have fractions, so we need to find a common denominator between 7, 8, and 56. 7, 8, and 56. But we know that 7 and 8 both go into 56, so the common denominator in this case is 56. We're going to take each of these fractions and multiply them by 56 to get rid of the denominator. So I have 56x squared over 56 plus 56 times 1 is 56 over 8 equals 56 times x over 7. 56x squared divided by 56 is just x squared. 56 divided by 8 is 7. 56x divided by 7 is 8x. Again, it's still not equal to 0, so I'm going to take this 8x and move it to the other side. And I'll do that by subtracting. That'll make this side 0. None of these are like terms over here, and I want to make sure they're in descending order as I do this. So x squared would go first, then the negative 8x, and then the positive 7. Now I know I need to factor. I've got an x squared. This is 3 terms. Nothing in front of the x squared, so I need to use a equals 1 here. I need something that multiplies the 7, but adds up to negative 8. The only thing that works in this case is negative 1 and negative 7. Both of these will set equal to 0 and find our solutions. In this case, we get positive 1 and positive 7. Both of these would be our solutions. So again, we're using a lot of our same techniques we've used throughout this class to solve equations, but now we need to go through and check and see if we have to factor them if we have something that's x squared or higher. Take a look at some more examples. Here we've got 2 terms. So we know for our 2-term factoring we can do a couple things. But first we have to look and see if there's any GCF. And this time we'll notice that both the terms have x's. So I should be able to take out a GCF in this case of at least an x. 7 and 2 don't have anything in common, so nothing else I could take out there. We'll take out an x. Taking away an x from 7x squared gives me 7x. Taking away an x from 2x gives me 2. Again, let's check the inside and make sure we can't factor it. There's no other GCF. And our only 2-term ideas we can do are sum and difference of cubes and difference of squares. We know we can't do difference of squares because it doesn't have a minus sign, and we can't do difference of cubes because it doesn't have a minus sign. And we know we can't do sum of squares because 7 and 2 aren't perfect cubes. So this is as far as it's going to go. We have x times 7x plus 2 equals 0. So we're going to set everything equal to 0, including just the x. When I set the x equal to 0, that's one of my solutions. So in this case, x equals 0 is a possible solution. Going the other way, we'll solve for x, and we'll find it to be negative 2 over 7. So in this case, my answers could be 0 or negative 2 over 7. Again, let's set this equal to 0. It doesn't really matter which side we move it to, but let's move all the terms to the left side in this case. I'm going to get rid of a negative 5k squared by adding 5k squared, and I'm going to add it to its like term. And I need to get rid of a negative 3 by adding a 3 to its like term. The whole right side is equal to 0, which is good. Negative 4 plus 5 gives me k squared. The minus 8k doesn't drop with anything, and the 3's cancel. So this is all I have left. K squared minus 8k equals 0. Again, it can't be any of the trinomial or the 4-term factorings. Now let's look first to see. We notice both of these have a k, so I should be able to take out a GCF of a k. And when I do that, I'm left with k minus 8. Both of these things multiply to equal 0, so we'll set each of them separately equal to 0. One of my solutions is 0 itself, and the other one is positive 8. Make sure you check for that GCF when you go through and you do your factoring. Let's look at our last two. So this one's already set equal to 0, so we don't need to go any further. There's no GCF between 4 and 49. So now we need to go through and realize that we're working with two terms. So it could be sum or difference of cubes or difference of squares. We know it's not sum of cubes because it has a minus sign. And we know it's not difference of cubes because 4 is not a perfect cube. But we do recognize 4 and 49 as being perfect squares and the exponent being a even one. So in this case, we're going to do difference of squares here. I'll take the square root of each of these terms. The square root of 4x squared is 2x. The square root of 49 is 7. So this would factor to be 2x plus 7. 2x minus 7 equals 0. And now we're setting each of these equal to 0 and solving it. And if we do it correctly, we should end up with opposites as our answer. So over here, I find one of them to be negative 7 over 2. And then I'll do the same steps on the other side. And I find it to be positive 7 over 2. So again, this one we used difference of squares. We take a look at the last problem. We've got 3x squared minus 27x minus 60. We need to get it set equal to 0. So I'm going to add 60 to both sides. 3x squared minus 27x plus 60 equals 0. I notice there's three terms, but I also notice right away that 3 is divisible into all three of these terms. So I'm going to take out a GCF of 3. And when I do that, I'm left with x squared minus 9x plus 20 equal to 0. Now because this is still x squared, I should still be able to find a way to factor this part a little bit further. So realize some of these might have more than one factoring technique to do with them. In this case, I've got three terms, and there's nothing in front of the x squared. So I should be able to factor this using a equals 1. What multiplies to 20 and adds to negative 9? I know 5 and 4 would work, and both of these would be negative. So when I go to factor it, I've got x minus 5 and x minus 4 from the parentheses. It still has the 3 on the outside, and we're setting it equal to 0. So now we would go through, and we would set all three of these parts equal to 0. However many parts are on the outside, we're going to set all of them equal to 0. Here I've got 3 equals 0, which doesn't make any sense, and because there's no variable here, I won't get a solution from that. When I do x minus 5 equals 0, I would find x to be 5, and x minus 4 equals 0, I would find x to be 4. So in this case, my only answers would be 5 and 4. So understand, even though I did factor out the 3, when I came to solutions, there wasn't any solution that was really with it. So we just kind of crossed it out and got rid of it. Realize if there was a 3x out here, that we would be able to solve for a solution. So for example, if it had been 3x, x minus 5, and x minus 4 equals 0, this still would have been x equals 4, and this still would have been x equals 5. But here I would have set this equal to 0, and I could have divided, and I could have found the other solution to be 0. So typically when there's a variable on the outside, you're going to get a solution. If there's no variable, then you won't have any solution with this. All of these, you need to know your factoring techniques well. So be able to look at it and identify how many terms everything has, and be able to decide which factoring technique or techniques you need to use. Making sure that as you do this, you look for the GCF first for every polynomial.